load commutated chopper, Morgan chopper and Jones chopper. This one more chopper circuit. In this session I will continue with mainly two types of choppers. One is I want to explain about AC chopper circuit and multi-phase chopper circuit. After discussing those two concepts, I want to discuss one small concept, that is what is the voltage control techniques in a chopper circuit. Okay, these three concepts I want to discuss in this session. Okay, that you concentrate on AC chopper. Yes, write down all of you. AC chopper. Actually, the purpose of using, why the name is given as a, this is AC chopper, means by using this circuit we can change the magnitude of AC voltage. The magnitude of AC voltage is changed by using this circuit. To change the magnitude of AC voltage at output side, so many circuits also there. By using AC voltage controllers also we can change the magnitude. By using transformers also we can change the magnitude. But AC chopper means it is also used to change the magnitude of AC voltage at output side by using solid state switch. That's why name is given as a AC chopper. Okay. Now see what is the circuit we are using for AC chopper. Okay. This is one diode. First you connect one capacitor. It consists of C1 capacitor with the polarity negative positive. Let's assume that initially this is the polarity, and we are connecting one diode also. Let this is D1 diode. This is the circuit we are using to change the magnitude of voltage level. Let this resistance is R1. We are using one more capacitor. This is C2 with a polarity plus minus, using D2 diode, and resistance is R2. Okay. Then two thyristors. This is T1 and T2. How we can change the magnitude of AC voltage is explained by using this circuit. Okay. This is T1, this is T2, this is T3, this is T4. Connecting with load. Assuming that we are supplying the constant current to the load. AC supply. Okay. The purpose of using AC chopper is, it is used to change the magnitude of AC at output. Magnitude of AC voltage. It is similar to that of AC voltage controller, but in this AC chopper is given. It is just like an anti-parallel thyristor, but to commutate this thyristor we are using T3, T4 thyristors. That means where T1, T2 is the main thyristors. T1, T2 is main thyristors. Then T3, T4 is T3, T4 is commutating thyristors. Commutating thyristors. For commutation of T1, T2, we are using T3, T4. That is where T1, T3 is one pair is used to control positive output. That is T1, T3 is one pair and T2, T4 is another pair. Positive pulse is controlled, and by using this negative pulse is controlled. Negative pulse is controlled. Okay. Now let us consider how these positive and negative pulses are controlled. Let this positive negative V0, this I0 is constant. We are supplying the constant current to the load. How these positive and negative pulses are controlled? I am explaining in one cycle of operation. Let this is one cycle of operation. One cycle of operation. Let this is T1 instant. Let this angle is let this is T0 instant. Let this angle is alpha. Okay. Let this is T1 instant. And this angle is alpha. And this is T1 instant. Okay. Now let at T1 instant we are triggered T1 thyristor. Once we can trigger T1 thyristor, then it starts the conduction, supplying the constant current to the load. Okay. Now at T1 instant we are trigger the T1 thyristor and it supplies positive current. Let at instant of T2, at T2 instant, here this is T1 instant. Okay. Then at T2 instant, whenever T3 thyristor is triggered, here T1 is conducting. Tell. At T2 instant, if T3 is triggered, now if T3 is triggered, then what happen? If T3 is triggered means now it is conducting like this. This is a path for conduction. Like this it is conducting. Once it is conducting, now whenever T3 is triggered, this is negative and this is positive, then T1 will be turned off. Now which is supplying the current to the load? T3 is supplying the current to the load. Up to what it will conduct? Again it becomes positive, then it becomes negative, then automatically T3 will be turned off. Let at T3 instant current is 0, then T3 will be turned off. At T2 instant we are triggered T3 thyristor, where it is turned off at T3. At T3 instant it is turned off because current becomes to 0. Then it becomes positive and it becomes negative. Initially this is negative positive, then it becomes positive and negative. Okay. Then let At T4 instant, this is the T4 instant. At T4 instant, T2 is triggered. Now if to control the negative, to change the magnitude at negative half cycle, if T2 is triggered, now how it's applying the current to the load, you tell me? Yes. If T2 is triggered, it's applying the current to the load in opposite direction. It supplies the current to the load in opposite direction. Like this it is applying. That is, it's applying the current to the load in opposite direction. At T4 instant, T3 is triggered. Sorry, T2 is triggered. This is T5. Then it's applying the current in the opposite direction. At T5 instant, what we are doing? This is at T5 instant, we are trigger the T4. Whenever T4 is triggered, this is positive and this is negative. This positive is connected here, this negative is connected here. Then with this polarity, then T2 will be turned off. Now who supplies the current to the load? Then T4 will supply the current to the load. This is the path. Now T4 will supply the current to the load like this. Then it becomes positive, it becomes negative. Then at T6 instant, then automatically T4 will be turned off. Okay, this is at this instant. Here T1 is conducting, here T2 is conducting. Here what about T3 instant? T3 is turned off. T3 is turned off at this instant. Here which is triggered? T3 triggered and T1 off. What is this instant? T2 is triggered. T2 is triggered. Then what is this instant? T4 triggered. T4 triggered and T2 is off. Okay. Like this we can control the magnitude of AC voltage like this. The magnitude of AC voltage is controlled by using this AC chopper. By using this AC chopper, the magnitude of AC voltage is controlled. Okay, understood? Okay, this is about what exactly AC chopper circuit. T1, T3 acts as one pair and T2, T4 acts as another pair. Clear? Okay, that you concentrate. If any circuit is given like this, what is the waveform we can expect? If it is asked like that, ready to answer. Clear? Then you write one more concept that is also important, that is multi-phase chopper. Multi-phase chopper. What you mean by multi-phase chopper means the parallel connection of two or more than the choppers. Two or more than two. Then that is nothing but a multi-phase chopper. Multi-phase chopper means it is a parallel connection of. It is parallel connection of. It is parallel connection of two or more than two choppers. Two or more than two choppers. more than 2 choppers. Then it is called multi-phase choppers. The purpose of using multi-phase choppers is to share the load current. To share the large load currents. To share the large load currents, we are using parallel connection of the choppers. Point to remember, in parallel connection, voltage remains same. There is no change in voltage, but which is added, the current will be added. But this multi-phase chopper, it is operated in 2 modes. It is operated in 2 modes. Multi-phase chopper is operated in 2 modes. One is in-phase mode of operation. In-phase mode of operation. Another one is multi-phase mode of operation. Phase shifted mode of operation. Yes, phase shifted mode of operation. Phase shifted mode of operation. Let us consider 2 buck regulator connected in parallel. I am explaining about 2 buck regulator connected, that is 2-phase chopper. If you connect 3 buck regulator, that is becomes 3-phase chopper. Like that we can analyze. These are the 2 buck regulator connected in parallel. This chopper or switch. This is load. This is a buck regulator. Okay, a chopper with in parallel a diode across the load, a chopper, diode across the load. Then it is nothing but a buck regulator connected in parallel. Okay, then in this case, if you operate with respect to chopper 1, then what is V0 equal to? Let V01 equal to dVs. V01 equal to dVs. Chopper 2, V0 equal to V0, that equal to dVs. Okay, because it's a buck regulator. Always V0 equal to dVs. V0 equal to V01 equal to V02 equal to dVs only. But it may be in phase mode of operation or phase shifted mode of operation. There is no change in output voltage. Output voltage remains constant. But based on phase mode of operation, based on in phase mode or phase shifted mode of operation, the current will be changes. If you take a in phase mode of operation, What do you mean by in-phase mode of operation means? Both the choppers are switched at same instant. Both the choppers are yes. Both the choppers are switched at the same instant. Choppers are switched at same instant. Same instant. Then it is nothing but a in-phase mode of operation. That means you switch like this. With respect to chopper 1, that this is I1 current. So applying I0. Like this we can switch. With respect to chopper 2, neglect the ripples. Neglect the ripples. We are assuming that the chopper supplying the constant current to the load. With respect to chopper 2, it is also switched at the same instant. This I2, this also supplying I0. Then resultant current I0 equal to both the choppers are switched at same instant. Then this is 2I0. This is 2I0. 2I0. This mode of operation is nothing but a phase shift, in-phase mode of operation. Then what is the resultant current? I0 equal to that is I0 average equal to I0 average equal to I1 average plus I2 average. Then 2I0. But what the average output voltage remains constant. This is dVs. Then what do you mean by phase shifted mode of operation? That means both the choppers are switched at different instants. Phase shifted mode of operation. Phase shifted mode of operation. What do you mean by phase shifted mode of operation means? Choppers are switched at different instants. Choppers are switched at different instants. Switched at different instants. Then it is called phase shifted mode of operation. Then different instants means like this. Let this is I1, chopper 1, chopper 2. Like this we are switching. Let this is I2. Here chopper 2 is switched. Here chopper 2 is switched. This is also applying I0. This also supplying I0. Then what is the resultant I0? We are controlling on and off only. Resultant I0 is like this. Okay, chopper 1. This is I0. There is no change. This I0. At different instants we are switching. Like this. Resultant I0 is I0 only. Here also you can get I0. Here also you can get I0. This is phase shifted mode of operation. Here currents are not added. Okay, that you know. We make some angle also. If you want to make this like this, you can trigger. Then we get the output like this. Here also you can maintain some duty cycle, different duty cycle you maintain. Then you get the output like this. At different instance we add triggering. Okay, at different instance we are triggering. This is phase shifted mode of operation. Here also you can get the pulse now. But this I naught remains constant. Okay, this is called phase shifted mode. Then what is I naught average equal to? I naught on, that is I1 average, that equal to I naught only. But what is the advantage of multi-phase chopers? The advantage of multi-phase chopper is, one is load sharing is possible to meet the large load value currents. Then that is one advantage. The second advantage is, for example, if only one chopper is there, instead of using multi-phase chopper, if you use only one chopper, then if there is a large currents are there, then to reduce the ripples in the large values of load currents, then we can use a large inductor. If you use large inductor, the filter requirement is also more. But whenever two choppers are used, then the current rating of each inductor will be reduced. Then what is the size of the inductor? Reduced. When the size of the inductor is reduced, what the size of the chopper circuit is also reduced. That is, advantage is load sharing is possible. Load sharing is possible. Another advantage is size is reduced. Size is reduced. Size is reduced. That is, magnitude of ripples are less. Magnitude of ripples are, ripple voltage is less. Magnitude of ripples are less. Ripple voltage is less. But magnitude of ripple is less. But ripple frequency is high. Magnitude of ripple is less. It may be ripple voltage or ripple current. But ripple frequency is high. Ripple frequency is high. Okay. This about what exactly multi-phase chopper. Simply remember, in multi-phase chopper, currents are added. In the case of which operation? In phase mode of operation. Okay, if any circuit is given, waveform is given, then you identify, is it in phase mode of operation or it is a phase shifted mode of operation. Like that you can answer. Okay, this about what exactly multi-phase choppers. The next one is, I want to discuss some important concept here. What are the voltage control techniques in choppers? That you will see. Voltage control techniques in choppers. Yes. Voltage control techniques in choppers. In general, voltage control techniques are broadly classified into two types. One is time ratio control. Time ratio control. Another one is current limit control. Yes, current limit control. Time ratio control and current limit control. Now see what exactly time ratio control techniques. time ratio control techniques. You know that, take the example of buck regulator. In a buck regulator, what is V naught equal to dVs? How to write d? T on by T, dVs or dVdc. You take Vs or Vd, any notation you follow. T on by T into Vs. That is T on into F into Vs. This is the average output voltage. That means the average output voltage is controlled by controlling on time or by controlling the frequency. This type of controls are nothing but a time ratio control technique. Based on frequency controlling or based on the time period based on the on time we are controlling. Based on that we are classifying this time ratio control techniques into two types. One is constant frequency control, another one is variable frequency control. First one is this based on this on time and frequency control, these are again classified into constant frequency control. Yes, constant frequency control. Another one is variable frequency control. Variable frequency control. Tell me, what do you mean by constant frequency control? Constant frequency control. Yes. Constant frequency control means keeping frequency is constant. Keeping frequency is constant. Keeping frequency constant. By controlling on time. By controlling T on. Output is controlled. Output is controlled. This, hence it is also called pulse width modulation technique. Pulse width modulation technique. Why it is called pulse width modulation control? T on is nothing but a pulse width. By controlling T on, we are controlling output voltage. That's the reason why it is called pulse width. T on is nothing but a pulse width. Take the one example. How it is, I will explain by using one simple example. Let this is T on, this is on time. Take the example for this one. This is T on. Let this is T off. This total is T. According to this, just for understanding, can you tell me that is Vs? Tell me. In the total T on is, can you expect 1 by 4th of T? No? Okay, just for understanding, take the example. T on equal to, in the total T on may be 1 by 4. Then what is T on by T equal to? 1 by 4. T on by T is nothing but duty cycle. That is duty cycle equal 25%. Then what is V naught equal to? 25% of Vs. Okay. Now what I am doing here? In the same case, I don't change time period. Time period remains constant. Now I will increase T on. Now this is T on. Now I will increase that T on. Now this is T. T remains constant. If the T remains constant means what is frequency? If T remains constant means frequency is constant. But in this, according to this example, can you expect what is T on equal to 3 by 4 times of T? 3 by 4th of T. Then what is T on by T equal to? 3 by 4. 3 by 4 means how much percentage? 75%. T on by T is D. Then what is V naught equal to? 75% of Vs. Like this we are controlling. In this case 25% of yes, here 75% of yes. Understood? That's why keeping frequency, time period is constant means frequency is constant now. This time period is constant. Keeping frequency is constant, then we are controlling output voltage by controlling on time. Then it is nothing but a constant frequency control or pulse width modulation technique. But the only drawback this one is by using this control, by using this control, by using this controlling small voltages, small voltages is difficult. Only drawback of this one, because maintaining the small pulse width is very difficult. That's the reason why controlling the output voltage to very small values, controlling output voltage to very small value, by using this controlling output to small voltages is difficult. Controlling output to very small voltages is difficult, but remaining all the advantage, and this is more preferable method practically. More preferable. This is more preferable. As compared to this method also, there is another method is there. Current limit control also we can use practically. Okay. Then what is the variable frequency control? Variable frequency control. Tell. What do you mean by variable frequency control? Yes. Variable frequency control means keeping either T on or T off is constant. Keeping either T on or T off is constant by controlling frequency. By controlling frequency, output is controlled. Yes, by controlling frequency, output is controlled. It is also called frequency modulation technique. Frequency modulation technique. This is pulse width modulation control, that is PWM control. This is PWM control. Frequency modulation technique. Frequency modulation technique. This is FM technique. FM technique. Then how it is? Take the one example. Keeping either T on or T off is constant. By controlling frequency, output is controlled. For example, let this is T on. This is T on. And this is total T. This is total T. Okay. Then according to this, let this is Vs and this is V0. According to this example, can you expect what is total T on is 1 by 4 times of T. This T on may be in the total 1 by 4 of T only. Then what is T on by T equal to 1 by 4. Then this is how much? 25%. Then V0 equal to 25% of Vs. This is according to this one. Now what I can do means, for the same example, this is now I don't change T on. I will maintain T on is constant, but I will reduce T off. Then this is T. This total is T. Then this is T off. T off. Now tell me, in the total T, what is T on? T on equal to 3 by 4 times of T. Then what is T on by T? Equal to 3 by 4. How much? 75%. Then what is V0 equal to 75% of Vs. Understood? That means here I am changing the frequency. Maintaining T on is constant. I am changing the time period. This is time period, now this is the time period. Then frequency is changing now, that's why it is called frequency modulation technique. This one, I am giving this example, maintaining T on is constant. You also try maintaining T of is constant. Then in that case also frequency will be changes. Okay, maintaining T of is constant, how the output is controlled, in that case also frequency is changes. That example you try. Okay, this is about what is variable frequency control. But what the drawback of variable frequency control means? For wide range of output voltage control, a large, that means we want to change the frequency for wide range. If the frequency is changed for wide range, then it causes interference. That means for wide range of frequency, what are the drawbacks of this one? What are the drawbacks? What are the drawbacks of frequency control? It causes interference. Because of you want to change the output voltage for wide range, then we can increase the frequency for wide range. If you increase the frequency for wide range means, then it causes interference. That is, then large filters are required. Once large filters are required means, which increases size and which increases cost. All these are the drawbacks with variable frequency control or frequency modulation technique. Understood? It causes interference and large filters are required, which increases size and cost also. That's the reason why, as compared to variable frequency control, which control is preferable? Constant frequency control is more preferable. That constant frequency control is nothing but a PWM technique, pulse width modulation technique. This I am giving this example by maintaining the which is constant. T-on is constant. Now we can increase the off time here. Keeping T-on is constant, we can increase off time. Off time means time period is increases, frequency changes. Then automatically, what about output voltage is also changes. That is another way, where maintaining T-on is constant, T-off is variable. But here I given only one example. Maintaining T-on is constant, T-off is variable. And you try maintaining T-off is constant. Then maintaining T-off is constant, where is the T-on? That you try. Okay. Then we can say that output voltage will be, from that we can analyze the output voltage also changes. Okay, this about variable frequency control or constant frequency control techniques. Then one more technique is current limit control. What do you mean by current limit control? This you already seen in buck regulator, boost regulator, you seen the waveforms also. Then what is the current limit control? By controlling current between minima and maxima. By controlling current between minima and maxima, I minima and I maxima, output is controlled. Okay. Then it is nothing but a current limit controlled. Then we know that what is V naught equal to dVs. Then V naught is nothing but a dVs. Then you also write I naught equal to V naught by R. What is I naught? You write I maxima plus I minima by 2. That is, by controlling current between minima and maxima, we can control the output voltage also. This I naught equal to I maxima plus I minima by 2. This is equal to, like this we can write. Okay, this about what exactly current limit control. But practical we are preferring this method also. Current limit control also we are preferring. Okay, this about in detail about what exactly AC chopper, multi-phase chopper, and what is the control techniques in chopper circuits. With this, with respect to types of choppers based on the commutation is completed. But I want to discuss class C commutation and class C commutation, and I want to give some introduction points with respect to SMPS also, switched mode power supplies. What are the circuits for SMPS? That is not there in GATE point of view. For other, mainly in IS point of view, SMPS concept is there. that just I will give the circuit and how to write the formulas that I want to explain with respect to. I don't want to give any derivations all these with respect to SMPS switch mode power supplies. Okay, there is some circuits are there with respect to SMPS that I want to explain. With that, choppers will be complete. After giving the SMPS circuit, then I want to solve some classroom workbook questions based on the types of choppers based for commutation. In the next session, I will continue with the Class C commutation and Class C commutation and some important points with respect to SMPS. Okay, clear? Consent.